Here's an interesting example where I want to find the equation of the tangent line and the normal line to the curve y equals square root of x over x plus 1 at the point 4, 0.4. Okay, so a couple things we have to do. First, we're going to find the equation of the tangent line. Secondly, we're going to find the equation of the normal line. If you don't know what a normal line is, we'll explain later. But remember, to find the tangent line equation, it's pretty formulaic. We say y equals f prime of a times x minus a plus f of a. And here what I mean by f of x in this context is my y, because y is an expression, is a function in terms of x. Okay, so what I need to do first of all then is calculate y prime. And that's kind of the trick to this whole question, really. So using to find y prime, I have to use quotient rule. Quotient rule says low, which is x plus 1, times the derivative of the top. And remember, I'm always treating x, square root of x as x to the 1/2 power. So its derivative is 1/2 x to the negative 1/2 power minus the top, which is x to the 1/2 power, times the derivative of the denominator, which is 1, all over x plus 1 quantity squared. Okay, now this can be a little tricky in terms of algebra here. The problem is this guy, I have a 1/2 and a x to the negative 1/2. Remember, that would mean the negative exponent puts it into the denominator. So how do you handle this? What I'm going to do is I'm going to multiply everything by 2x to the 1/2 power. And the reason that works is because when I distribute across this term, the 2 and the 1/2 cancel out to give me 1, and x to the 1/2 times x to the negative 1/2 gives me x to the 0 power, which is also 1. So when I do this, I end up with x plus 1 times, I'll write it in purple just to make sure it stands out, 1 minus, when I distribute 2x to the 1/2 times x to the 1/2, I end up with 2x to the first, which is just x, all over 2x to the 1/2 times x plus 1 squared. Okay, so we can simplify my derivative a little bit then. In the numerator, I have a negative x plus 1. In the denominator, I have a 2x to the 1/2 times x plus 1 quantity squared. And be careful, the x plus 1 in the numerator does not cancel out with the x plus 1 in the denominator, because this is actually negative x plus 1. Okay, so they don't cancel out. Alright, so there's my derivative. Now, to find the tangent line, again, I'm going to use this formula here. I just have to say then, that's going to be y equals y prime of 4, x minus 4, plus y of 4, which we already know. I'm going to write it as 4/10, or maybe I should write it as 2/5. Okay, that's the same thing. Alright, so if I plug in 4 into this derivative here, I have negative 4 plus 1 over 2 times the square root of 4 times 4 plus 1 quantity squared. So that gives me a negative 3 in the numerator. In the denominator, I have 2 times 2, which is 4, times 5 squared, which is 25. So I end up with negative 3/100ths. Okay, so then my tangent line can be written as negative 3/100ths, x minus 4, plus 2/5. Okay, if I want to simplify this a little bit, that's going to be negative 3/100ths x plus 12/100ths. Okay, so maybe it'd be useful to write this in terms of 100ths. So to get 100 in the denominator here, I need to multiply by 20. So I end up with 40/100ths. So then my tangent line has equation y equals negative 3/100ths x plus 52/100ths. And you could simplify the 52/100ths if you want. I'll just leave it like that for right now. Why not? So there's my tangent line. Okay, now, what about the normal line? So the normal line runs perpendicular to the tangent line. Okay, so if it runs perpendicular to the tangent line, that means that its equation is very similar to the tangent line, except the slope is negative reciprocal the negative reciprocal. And let me use f prime of a here. Okay, so that's the relationship between a line and its perpendicular, is they have negative reciprocal slopes, but it passes through the same point. So I'm going to have x minus a plus f of a again. Okay, so that means if the derivative of at 4 was negative 3/100ths, then my normal line slope is going to be 100/3, the negative reciprocal, and I'm passing through the same point, so it's going to be x minus 4 plus 2/5 again. Okay, so simplifying this, I end up with 100/3 x, 100 over 3x, minus 400 over 3, plus 2 over 5. Okay, so I need to get common denominators here. My common denominator is going to be 15. And so the way I get a 15 in the first term is multiply by 5 over 5. So 400 times 5 would give me 2,000. And then I have to get a 15 over here. I didn't mean to multiply by 3 over 3. So I end up with a 6. Okay, so finally I end up with 100 over 3x minus, what is that, 1,994 15ths. And there's the equation of my normal line. Okay, so here we are on Desmos.com, and you can create an account, and it's free, so I recommend doing that. This is a very helpful piece of software. Alright, so I'm going to use this to graph. First of all, let's get a graph of my function. So that's y equals, I can come down here and say square root of x, and use a forward slash to give me a divides. And so there's my square root of x times x plus 1. And I can drag it around, zoom in and out however I need to. There's my function. Okay, so we're interested in the tangent line and the normal line at the point right here at 4. Okay, so I'm going to come down to graph my tangent line. I already have the equation, so it's going to be y equals negative 3 over 100 x. Okay, so you can see this black line showing up. That's not exactly my tangent line, right? Because I need a plus 52 over 100. And there it is. Alright, now for my normal line, I'm going to say y equals 100 over 3 x minus 1,994 over 15. And there it is. And you can see this red line kind of runs exactly perpendicular to the black line. And the black line mirrors the purple line so closely that it's hard to see the difference there. Okay. I hope this makes sense. If you have any questions, please let me know. I'd be glad to help. And thanks for watching.